Hey, what's up, guys? This is Chung here. Let's take a look at today's daily challenge problem, number 91, decode ways. So, this is one of those very classic DP problem. Okay, basically you're given like a string of digits. Okay, and each digit might represent one of the uh, the characters, right? The letters from A to Z. So A is 1 and Z is 26. And it asks you to what? To find the total number of ways to decode it, right? So for example, right? So for example, this is 1, 2, right? Basically, there are two ways to decode it because we could decode it to A and B, right? That's one way. The other one is 12 in total, which is 12. That's this L. So that's two ways. And 2 to 6, similar, right? So we have 2 to 6, and then we have 22, 6, and then we have 2 and 26. That's three ways to decode it. And yeah, so I think the reason this one got a lot of downvotes is because of this zero special corner case, which is zero, which means that anything that's have if as long as this string has a leading zero, then we always return zero because if 0, 1, that's not a basically valid string here. Even 0, 1, 2, 3. So basically, as long as the first letter is 0, we always return 0. So that's that. So this one is like if you guys remember, there's a like problem caused the ways you can reach the a certain stairs, the stairs, right? Let's say there's like n stairs, n steps. And at each time, you can either uh, climb one or two stairs. Okay, right? And then it asks you to calculate how many ways you can reach the n stairs. So actually, this problem is almost the same, but the only difference that so for this one, every time you can either do a one or two, but for this one, there are some conditions you need to check before making this one or two move. So, so what we do is we just define like a DPI here, right? So it means that, uh, so it means that for the first i's digits, how many ways we can decode? And then it's going to be the what? It's going to be the total of the DP I minus 1 plus the DP I minus 2. Because the biggest number we have is 26. So which means that we can only go back to one or two steps. But so for this problem, the DPI and I minus 1 DPI minus 2, so each of them will have like a conditions we need to check. So first one is the DPI minus 1. So this one means that we're gonna use the current I to be the single letters to be decoded. So which means that so to be able to decode from this one, so the current I is Si or Si minus 1, right? Cannot be 0. So that's the condition. That's the condition we need to check. We need to check for this DPI minus 1 because if the current one is 0, let's say we have 1, 2, 0, and 3. So for example, this one. Okay, let's forget about this one. And let's say we are at this location here. You know, so I minus 1 means that we're gonna decode this one, the current one, as a single letters, right? And then we're gonna use the DPI minus 1 to get the current one, but 0 is not a valid mapping here. So that's why we cannot do this accumulate dpi minus 1 if the I is 0. And similar for this dpi minus 2. So to be able to decode I minus 2, it means that we want to use this this two digits as as one of the letters, right? So which means that what is the letters for that? So it's going to be from 10 to 26, right? Because A is 1, so and 10 so the first letters that can give us two digits is is 10, right? And then the last one is 26. Yeah, that's it. So basically we just need to check if this S I minus 2 to I, if this one is between the 0 to 26, then we can use this dpi minus I minus 2. Yep, I think that's it. So let's do the coding here. So and always, right, we have an S, and then we have dp, right? The dp at the beginning, right, everything is 0, right? And then we have a equals to n plus 1, I guess, right? So and then for dp 0, right, it's 1. So it means that, so for this kind of counting a dp problem, we always we most of the time we initialize dp0 is 1. It means that if we don't have anything, that's still one way to do the decoding. So in this one, it means that if we don't have any digits, there's still one way to decode, which means it's nothing. Okay, and then since the dp translation function is that dp like we might need to use dpi minus 2, we also need to initialize dp1 in this case. So for dp1 means that dp1 is also 1, right? So if there's only one letter, if there's only one digit, right, it doesn't really matter. So the digits can only be from 0 to 9. Okay, because for 0 will be we're gonna handle this separately. So basically we only have 1 to 9. And 1 to 9 there always be only one ways of decode this thing. So since we have initialized 0 and 1, then we can just start the for loop here. We from a range here, start from 2 to n plus 1, right? And then and yeah, so let's check if if the I minus 1 is not 0, right? Because since here we are using a 1 based, but the s is 0 based, that's why we do I minus 1. And then we have dpi equals to dpi minus 1. So that's to use this current to use the si minus 1 as the letter. And that's why we can just use the I minus 1. Else what? And then for the two digits case, uh, if the two letters, right, is within the range of 10 to 26, so that's going to be the int of the s I minus 2 to I, right? And we convert that into an integer. If that one is within the range of 10 to 26, then we can do a dpi plus we accumulate, right? I minus 1. So here it doesn't really matter. You can do this as well. It doesn't matter because at the beginning dpi is 0, and so here we can either use like plus equal or equal. The result is the same. Yeah, and that's that. And then in the end, we simply return the dpn or dp minus 1. Yeah, so that's it. And then the special case, right? Special case is like I said, it's a 0 case. Basically the first letter is 0, then we always return uh, 0. And also if the s is empty, right, then we also return 0. So which means that if not s or s0 equals to 0, then we'll return 0. That's how we handle this 0 case or leading 0 case. Right, so here, right, so here is the okay, yeah. So I think that's it. Submit. What? 26? Ah, really? Did I? DPI. Oh, yeah, sorry. Here, DPI minus 2. Okay. Yeah, so I mean, time complexity, right? It's just the O of n, right? Because there's only one single for loop here. Yeah, and other than that, it's just like a standard DP. Actually, it's just like the stairs, right? Problem, and the only difference is that we can either we can basically we can get to the current state by uh, by making the move from DPI minus 1 or DPI minus 2. And the only difference is we have to do a check for those two cases. Yeah, and I think that's it for this problem. And thank you so much for watching this video, guys. And stay tuned. See you guys soon. Bye bye.